All right, hello everybody. In this video, we're going to be looking at justifying and supporting student reasoning and algebra classes. And that's me, Mike Wilmus. I'm a math teacher at Fridley High School in Minnesota. I've been there since 2008. So the summary of this presentation is to talk about designing curriculum to educate parents on the mathematical practices taking place at Fridley High School. And our topics are going to be discussing mathematical reasoning and how parents can support this, some problem-solving examples, and how to solve algebraic equations, and then some common misconceptions in math classes. So the goal of this is to empower the parents to help their students with their mathematics. So some inspirational quotes to help us understand mathematics and to get us going on the right step. First one here by Henry Poincaré. Mathematicians do not study objects, but the relations between objects. And it's not that I am so smart, I just stay with problems longer, by Albert Einstein. And it isn't that they can't see the solution, it's that they can't see the problem, by Gilbert Chesterton. And so for this, I think a lot of these really resonate with me, such as the middle one. It's not that I'm so smart, it's just that I stay with problems longer. That's going to be one of the main threads throughout this, talking about the productive struggle that students will have with math problems. We want them to start a math problem and then not to just exactly know the solution and know how to get to the solution. We want them to figure out their own path to the solution, to have a productive struggle. It's really important because in the real world, you're not just given a formula and told to plug in numbers. You have to figure out what the formula is. You have to wrap your head around what the problem is asking, such as the bottom quote. It's not seeing the solution that's the problem, it's seeing the problem and figuring out what even the problem is, and then figuring out what tools you have to solve it are some of the important steps that we use in our real world. So one of the things we want to do is focus on what questions to ask and then work on how to solve the problem. And some of the ways to get to that are using number talks to develop algebraic reasoning, and then using what's called a low floor, high ceiling problem to engage all the learners in the class. So an example of kind of a low floor, high ceiling and another mathematical reasoning problem would be the box problem. And this is a famous Algebra 2 problem that a lot of textbooks and classrooms look at. And so what this is asking is they give you just a blank piece of cardboard that's 21 centimeters by 30, and we want to go ahead and make cuts on the corner of this piece of cardboard, and then we want to be able to fold it up so we can make a box. And we want to find out what X cut on the corner would give us the maximum volume for this box. And you can see if you make a really small cut, X cut, it would be a really shallow box, probably not the not the maximum volume. But if you make a bigger cut, it would be a really tall and skinny box. So we want to figure out what X cut would give us the maximum volume. And so to do this, you realize this turns into a quadratic equation, and then even turns into a cubic equation when you look at the volume. Then you need to maximize that equation. And I won't go through it all here, but you end up having to graph it. Then you find the maximum point. And it's a really good problem. It encapsulates a lot of our Algebra 2 skills. And it's really nice because it's so easy to get into. It's a very low floor to start this problem. Anybody can just guess at what the X is, but to actually calculate what the X is, there's a bunch of different ways to do it. That's a high ceiling. And then showing all the different ways to do it, it's a very high ceiling. So another example of a low floor, high ceiling problem would be something like this. Taking a look at a number, this could be a number talk, a warm-up you do in class, or you could do this at home with your students. You could look at these tables and ask, how are these relationships alike, and how are they different? So we can see we have input, output, and then XY. So obviously I see some differences right away. We have input, output, and XY. Those are labeled differently, but they're actually pretty similar too, because that's what X and Y are, input and outputs. Then you can look at the numbers, and then you can look at the patterns. First one's 0, 4, 8, 12, 16, so that's going up by 4. The next one's 6, 7, 8, 9, 10, so that's going up by 1. And so this is a really good way for students to talk about what do they see. Everybody can do it. There's no right or wrong answer, and you can scale this up to be more difficult in nature. Another low floor, high ceiling problem, which is a more specific one, is called a number talk. And number talks are designed to help aid students in developing higher level algebra skills. So the question here is how could we determine the number of border tiles around an 8x8 pool without counting them one at a time? And so they want students to look at this and then to ask, what are some ways we could think about this? And then we could think about a 9x9 pool. How about an n by n pool? Or how about an n plus 1 by n plus 1 pool? Could we create a rule for this in general? And for having students think about this complex problem abstractly, they really start to develop those algebra skills and figure out what algebra is useful for. And so for the parents, this is what this presentation is geared towards. There's some really good online resources out there. So if you Google number talks on YouTube, you can find some great examples. And also the Jill Boler website from Stanford, the U Cubed website she has lots of really good low floor, high ceiling, and number talk examples. So the next few slides are going to talk about some tips for parents on how to help their students working through algebra. And so an analogy we like to use in math class is called the scale analogy. And so whenever we have a mathematical equation with an equal sign in the middle, that means both sides are obviously equal to each other. And in order to keep the sides equal to each other, we need to remove the same thing from both sides of the scale to keep that balanced. So for example, if we remove a 3x from the right side, we need to remove a 3x from the left side. And so the common theme here is to keep both sides balanced. And so this is really helpful for us to remember about what is what's an allowable move in mathematics class and what isn't. And so in general, whatever you do to one side of your equation, you need to do to the other side. So if you divide one side by 2, you have to divide everything on the other side by 2. And here's a good visual of seeing like the 3x plus 5 and the 5x plus 1. You can see how these have been taken away, and we're left with 2x plus 1 and 5. All right, so this was a few tips for parents on how to go back and work through some algebraic equations, how to engage their students in low floor, high ceiling, and number talk problems. And thank you for listening.